In this infographic, we'll talk about the first type of projectile motion. In this type of projectile motion, the object is traveling completely horizontal, and there is no vertical velocity. In this example, we have Coyote here running off the edge of a cliff. Let's say the Coyote is running at a velocity, at a speed of, let's say, 5 meters per second. And we want to find how far he lands on the bottom of the cliff. Here, all our yellow words are describing our vertical travel, and all the blue letters here are describing our horizontal travel. Well, as you know from before, for any projectile type of motion, we always need to find a time. So now we have to ask ourselves, though, where are we going to find the time? Are we going to find the time using the vertical component or the horizontal component? Now, if you look at our data here, in the blue here, we see that we have two unknowns. Both the distance is unknown and the time is unknown. So this here was for our x component. Let's look at a y component. Well, we know because Coyote is running horizontally, initial velocity in the y direction is 0. There will be acceleration to gravity at negative 9.81 meters per second square. And he will fall a distance of, let's say, for example, in this example, 10 meters. And again, we want to find time. It is obvious that because we have only one unknown, our time here, it is easier to find our time using our y variable, our y direction, rather than the x direction. So if we look at our kinematics equation, we realize we need to use the formula d equals vi t plus 1/2 a t squared. Luckily for us, vi is 0, so it simplifies our term. To rearrange for t, we get t equals 2 times d divided by a square root. And if you plug in all the numbers, you'll find that the time for Coyote to fall off, to travel to the bottom of the cliff, is 1.43 seconds. Now that we have the time of flight from our y numbers, we can use the same time for our x direction. So now we know our time is 1.43 seconds. So now we can use the formula d equals v times t. D equals 5 meters per second times 1.43 seconds. Our distance here is about 7 meters. So we know that at the end of the day, Coyote will land about 7 meters from the edge of the cliff. So the key to solving this question was to find the flight time, how long Coyote was in the air for. And in this case, it was easier to find the flight time using the vertical, the y components, because we have more data. We have the initial velocity, the acceleration due to gravity, the distance traveled, and the time to find our equation. Once we have the time, we can use that time in our x directions to calculate how far Coyote travels off the edge of the cliff.